Hi, everyone. It's a pleasure to be here today. So, as you probably saw here in the conference, all the talks are about AI. AI is everyone is everywhere, everyone is pushing for AI and focusing on AI. We can see it in the, and we can see there is a high demand to bring AI into production. We can see it in the surveys that says that companies increase their budgets this year to use AI. We can see it in the market reports that shows that AI will go from $5 billion to $50 billion within 5 to 6 years, and with companies that already implemented AI in such a way. And why does it matter for you? Because your managers, your company is coming to you and is asking you to insert AI into production. And the question we ask ourselves is, how can we implement an unfamiliar technology into a maintainable, mature environment that needs to keep high SLA? So here it is Benji Kalman, the VP Engineering and co-founder at Root.io, with 15 years of experience in the security area. Thank you, Benji, for being here.
Thank you very much. And with me here, of course, is Shiran Melamed, who has over 20 years of experience in DevOps and is the group leader of JFrog in DevOps.
Great, thank you. So a few seconds about JFrog, who is familiar with Artifactory? Yay. So when JFrog was first founded in 2008, the challenge in the industry was managing binaries and images, and JFrog created Artifactory tool for that. But within the years, challenges has changed, and today there are much more things to handle. So JFrog is a complete platform that handles other challenges like security aspects, machine learning, and just now we have a new MCP server called JFrog Fly that you can speak with your private registry, private repository. So now you can ask, what is the latest release that I can use now? What is the securable that passed all scans? So if it's interesting for you, we are in the beta stage. You can scan this QR code.
And I'm not going to ask you guys who knows what Root is, because only the two people here from Root will know that. And that's the burden of being a smaller startup, talking with the wonderful JFrog here on stage. But what Root does, and I'm so glad you asked, is we basically provide what we call agentic vulnerability remediation, which means we get an input, and the input is a container or a package or anything like that. We scan that and we identify the vulnerabilities in the open source components inside. And then we set out to fix and backport any vulnerability inside that package. I'm not going to go on too much because it's a little bit of a spoiler to what we're going to be talking about further on in this talk, so stay tuned.
So before we start speaking about our scenario and what we are going to solve, let's speak about what is AI agent. So we have a chef. The chef gets a recipe, and he's working according to predefined instructions. Maybe you remember the chef configuration tool that we all used to use in the past. So the regular chef is working according to the instruction, and he's not moving from that recipe. The AI chef gets the ingredients, thinks what he can cook, then he cooks it. But if something goes wrong, it's not tasty enough, he will write the recipe again and do another meal, another dish. So the AI chef is taking decision throughout the process. He is learning within time, and his goal is to get to better outcomes. So this is regarding that. And the scenario that we will touch today is compromised open source packages. So what we will show today can, with AI agent and Argo Workflows, can fit any other scenario, but in our case, we will touch this one. And why? Because lately we see a lot of hype in the security vulnerability issues. So a few weeks ago, we had the largest NPM attack, which a lot of open source packages were compromised. You can see a short list of those components. And this has become a big issue that we want to handle. And together with Benji here, we will solve it. So what we need to do when we have compromised package? We need to find a new package, a new version for that package that is clean from vulnerabilities. To do that, we need to research. It takes time. We need to code with the new package. We need to change our code. We need to pack it, test it, and eventually deploy it again, which takes approximately 14 to 75 hours. And this is only for one package. What we can do to reduce this time? AI. I wanted you to shout AI. So AI. And Benji, how can we do it with AI?
Excellent question. So how could an AI agent fix a CVE or even a bunch of CVEs? So I'm going to start us off. We have your images, you have your packages. You start off, you scan them with your local vulnerability scanner. Hopefully you're using the wonderful JFrog to scan your images, and if not, whatever other scanner you have. They provide a list of those CVEs which you want to go out and fix. And then we start doing the obvious thing. So the obvious is basically if there is an applicable fix available for that version that you're using. So let's say you're using Debian Bookworm, and Debian Bookworm have already fixed that vulnerability. You're not afraid of any breaking changes. You can simply upgrade them. And if you're good DevOps people, which I'm sure everyone in this crowd who stayed till the very end of KubeCon is, then you'll do that yourselves. And if it's an application, so if it's an application level vulnerability, if it's in Python, it's not a breaking change to another major, you'd upgrade that as well. But the issue is that there are all of these hundreds of other vulnerabilities which you don't actually have a fix for. And that's when we begin to work with our little agentic fleet. So the first thing that we would do, the research, we'd send that to a bunch of agents to basically begin researching, crawling the internet, identifying and doing the complex logic to be able to identify, is there a fix for this vulnerability anywhere? Has anyone fixed this anywhere in the world? And identify those fix candidates. We'd then basically be able to take this and give this to a separate set of agents who would be able to build that package and apply the specific fix to the version of the package that we needed without introducing breaking changes. Now, this is obviously a little bit of a complex thing to do for anybody, and even a basic agent, if you use Claude Code, it's not always able to necessarily apply the best fixes in the smallest way. So we'd also then have some type of agent which would run tests and verify that we weren't breaking everything and that we'd had actually secured that. And if we'd done all that well, we get a lovely fixed image at the end of this with all of our vulnerabilities fixed. So this is how an agent could solve, say, a single vulnerability. But the question that we've come to answer is, how do we solve all the vulnerabilities? So how do we solve it for thousands and thousands? And the answer is, of course, orchestration. So what do we need in order to orchestrate?
So we have few requirements for that. So now when we have multi-processes, we cannot do things manually, right? So we need centralized place for the logs and the metrics to see that everything is working properly. We need a retries mechanism, error handling mechanism to fix issue when they come up, and we need it to be automatically. Of course, dynamic resources, we need CPU, we need memory, we need it to scale up, we need it to scale down according to the number of processes we are running. We need fast deployment and fast rollback, and human approval gates, because maybe we want to have some intervention, and we'll speak about it a bit later. And chaining tasks, because we have few workflows, maybe even few agents that need to handle the situation. And we are going to do it with Argo Workflows. So when we will use Argo Workflows, when we have complex and multiple step workflows that we want to handle, when we need container isolation, each container has its own data, its own resources, and of course, when we want to do it at scale, we can run in parallel multiple containers. And how does Argo Workflows answer our requirements?
So how does Argo do this? So basically, this is a table which talks and compares Argo to a couple of other options. For the usage of our time, I'm just going to sort of concentrate on what Argo is providing us, Argo and Argo CD. So in centralized observability, the fact that we have a unified UI with Prometheus and Grafana is very, very helpful for us to be able to have all of those metrics immediately available to us. Retries and error handling, well, you have a per step retry and back off policies. This is going to be important because because as we mentioned, the agents could go haywire. There could be stuff that goes wrong. We need to have some ability to control the output of what they're doing and retry if necessary. Dynamic resource scaling. So obviously, KubeCon, it is Kubernetes native. It auto scales with the cluster, and also we use Carpenter behind the scenes to allow us to, well, cheaply, again, going back to the fact that we're a startup, scale up and scale down resources as needed without burning a hole in our pocket. Rapid deployment and rollback. So having GitOps-based sync and one-click rollback is incredibly helpful. We're going to need to experiment a lot of times with different models, with different agents. We're going to need to be doing that very quickly and rapidly. Human approval gates, because ultimately we're going to need to make the decision. We're going to need to have some humans in the loop so that we can gain trust in the systems that we're building. And obviously we have DAG and conditional logic to allow for chaining tasks. So all of this means that, and you might have guessed this from the start of from the title of this session, that we are wanting to use Argo in order to solve this. The question then is, how do we do this specifically? So we have 3 different layers that we are using in Argo in order to create the solution that we have here. The first is the Argo CD layer. So this is what we use. This is what deploys both the workflow templates and the cron workflows that we're using. So we're going to use, sometimes we're going to spin up a workflow all on its own. Sometimes we're going to have a scheduled cron to run and say on all vulnerabilities that have been opened in the last day or so that we want to examine and understand how we can fix them. It's going to manage RBAC and secrets. It's going to manage the Carpenter node pods, and it's going to allow us to, using GitOps, to sync per environment. Then we have the Argo Workflows layer. So this is what's, first of all, going to execute our agent containers. So each one of our agents is going to be inside its own container, and that's going to be run as part of this workflow. It's going to have the DAG, which is going to control the Argo set of steps that needs to happen. And we're going to have 2 other things here. One is S3 artifact persistence. This allows us to have information that we can share and store between various steps of this process. And we're going to have Jira integration in this specific case because we want it in order to update tickets and change statuses and everything else as we kind of handle this. And then the final layer, the fundamental sort of layer, is the Carpenter layer, which allows us for the just-in-time node provisioning, instance optimization, and automatic consolidation. So now, digging one step deeper here, let's go into the Argo Workflows layer and peel back what it is that we're doing. So here's a lovely picture of Argo, as you all know. And there's 3 different things here that I want to pull out. The first is the orchestrate. So this is a template that we're using in order to orchestrate. It can run many, many, many different CV research templates in parallel. This allows us to say if we get a single image and we have multiple vulnerabilities in it, so this will orchestrate spinning up a flow for each one of those vulnerabilities. It allows us to say if we want to, on a daily basis, recheck and re-examine all of the open vulnerabilities that we have to run this across all of this. It queries our own database for any unpatched CVEs that it might have, and then it submits individual research workflow requests dynamically. The second is our DAG. So that's the CV research template. This is going to execute the research agent itself, and it's also going to be in charge of converting to Jira format, as I said, just because we're using that as our task management system. And then finally, we have the research agents template. So this has all the tools defined, which are called by our DAG. And it has a very clear input and output, which is going to be very important to us. And to explain a little bit more about that, I'm going to hand this over.
So let's go deeper into the CV research code and see what we have there. So at the first part, you can see the input and the outputs. The inputs, we are getting them from the previous step. They are kept in the database, and then we read them. The CV ID, the package name, the package version. Those inputs will go into the prompt of the AI workflow. And in the outputs, we can see the research summary. So the input and the outputs needs to be predefined because this is the contract between the 2 processes.
So The second thing that we're going to dig into here is just the various n variables. And there's just a few things that I want to call out here. So we have some obvious stuff, which is defining which environment we're running in, and this we took off our development environment. But some other things to note here is, first of all, we have the max scrape size. So that's additional input that we're providing and that we can change dynamically to our agents. That's going to explain how many times we're going to allow it to run wild in this sense. In this case, 80,000. So somebody's gone a little crazy in terms of what they're doing. But the other thing which is important to note is the different models, because we're using models, different LLM models, also as environmental variables. And because we need different models for different parts of the agents that I mentioned, because some of them are more optimized at doing different types of tasks, so we want to be able to define each one of these, and we want to have an easy way, and this is an easy way of us to simply experiment and switch them in and out by using n variables.
And another interesting thing to see here in the code is that we have another image. So we are calling another image. We are calling another workflow, Benji?
So yes, indeed we are. What we're doing is we're calling on the AI agent as its own separate workflow. And here is the workflow in all of its beautiful glory. Now, really, I'm just putting this on the screen to show off. You don't need to dig too much deeper into this. The main thing here to understand is that there's a complex workflow which the agent itself is running quite apart from the Argo workflow that we've been doing. So it's doing primary research and context reduction and secondary research and checking and yada, 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 yada. And the question that's actually important to us to ask is, does this make sense? Does it make sense as practitioners for us to set up systems which have workflows inside workflows? So we have Argo workflow with its own predefined steps and everything on one hand, and then as part of that, there is a subsystem which is creating its own workflow. And does this make sense, or does this introduce some type of insanity into our process? So we're on the side of not insanity in this talk. And the reason for this is as follows. First of all, separation of concerns and teams. Going back to the very basic fundamentals of we as engineers understand this, we have different teams, we have different capabilities in them. As VP of engineering of a company, I need to hire my back-end engineers, my DevOps, my AI engineers. They each have their own different skill sets, and they each have their own different abilities that they can bring to the forefront. We want the ability for the AI engineers to be able to focus solely on developing agents and the type of workflows that are involved there, and only on that, and not needing to worry at all about anything that has to do with the DevOps side of things. And the flip is also true. We want our DevOps engineers to be able to continue to develop as best as possible everything that has to do with the DevOps workflow without needing to worry too much about what those crazy AI engineers are getting to behind the scenes. And in order to do this, this is exactly the contracts between workflows that we've seen time and time again in our practitioning. So this is defined APIs, contracts between, say, backend and frontend. This is something we're all familiar with. Defined contracts that we already have today between, say, backend and DevOps. This is an additional team, an additional setup that we need to do to have the clearly defined contracts between these sides. Which is exactly what we sort of showed earlier. Those defined inputs, those defined outputs, which, so long as those remain steady, we can experiment as much as we want inside the agentic side and not break production, for instance, while still allowing ourselves to allow the AI agents and the AI engineers who power them as much flexibility as we can to get towards rapid development. The third thing here is around monitoring, and the difference that we have in what we need to do for monitoring workflows and what we need to do to monitor agentic AI. There's been a few talks here about OpenTelemetry kind of solving everything and all of this in this KubeCon. I don't yet believe that's the case. There are different types of monitoring that we need for AI agents, which are not quite like Grafana and Prometheus. Things like LangFuse and LangChain that people are using, which also allow you to step directly into a single step inside a work chain that's happened and be able to repeat that flow. And there's these type of differences we think are going to remain. And therefore, again, this is separation of concerns of how we would want to manage this. And then finally, and if, again, like you're at the end of this conference, so you're tired. So if you only remember one thing from this talk, please remember this. Use AI only when necessary. Do not believe the hype. AI is great for a lot of things. It's how we built our company, for instance. However, it is still immature. It is still developing technology. It is still something which is not battle-tested and battle-hardened. It is still mostly written in Python and not, say, in Go or Rust or C, which are far more, which allow us to run things much faster and much more easily. So when there is a need for that smart chef, so when do you need to solve a vulnerability in a thing which is unknowable ahead of time? Use AI. When you need to, I don't know, orchestrate a workflow, when you need to convert something to Jira, when you need to do something simple and predefined, continue using the baseline tools that we have here, and we think Argo is a great baseline tool. Having said that, there are still some challenges.
Yes, so we solved our problem. Now we are not handling only one process, but multiple vulnerabilities. With the AI, we reduce the time, but still there are challenges. So the first challenge is the limitations. Even if we will take the obvious limitation of infrastructure in a cloud provider, EC2 are finished. Still, there are other limitations like third-party components, DB rights, limitation, etc. Second, and we mentioned it already a few times in the presentation, we need to decide and think if we want to allow human intervention, when, how to present it, how much flexibility we want to allow humans to interfere in the automation, in the automatic process. And I think the most important challenge is context handoff. Because Argo gives us isolated ephemeral containers to run our agents on, which is really, really great. But when it comes to multi-agent system, we need one agent to be familiar with the context of the different agents that run before him. Take for instance, a testing agent that failed to pack the image. Before it will go down, it will spin up a patching agent, and this patching agent needs to know the context of the failure in order to effectively fix the issue. Otherwise, it will be a big problem. So today we are doing it with MD files, which are constant and can save our context. But in the future, we'll probably need to go to a more mature solution like VectorDB or other solutions that there are today in the market.
So yeah, so just before we kind of end, I'll just say this is a journey for us as we've been sort of building this. We're learning about these technologies as we go along. We found some really incredible steps forward just using the technologies that already exist. And I'll go back and repeat what I said again, which is if there is a technology that already exists out there, which is battle-hardened and tested, and you think that that's the right solution, use that. And if someone's pushing you to use an AI tool instead, kindly tell them to go away. That's it from us.
Or come to you.
Or come to me, exactly. That's it
you.
from us. Thank you very much.
You have fun.